So, as we all know, the semester is coming to an end. We have 2 weeks of lecture. Only 2 weeks. And the 3rd week, test. And probably immediately exam, or 1 week between the 2. But there's only 2 weeks of lecture. And in class, we are still in differentiation. But from the scheme of work, we still have integration. And integration is more elaborate than differentiation. And apart from integration, we still have trigonometry to do. So that's like 2 other topics. Okay. So the last time we met for MTH, I think 2 or 3 weeks ago, I think that's 3 weeks ago, we did some differentiation of some functions, and we also did implicit differentiation. So as we are going to the application of it, we will try to explain some of those things. Okay, let me start from here. As you know, normal derivative, before I go into the application, normal derivative, if you have the function y equals to ax is power n, where a is the coefficient and n is the power. Derivative, that means the derivative of y with respect to x means you are going to multiply the power with the coefficients, then minus 1 from the power. This one is known as the general rule. So this is the general rule of differentiation. Then you have the other rules. You have the products, you have the quotients, you have the function of the function also, including others. And we have the parametrics differentiation, whereby we have something like y equals to something like y equals to 80 and x equals to 80 also. Like 2 different, now in this case we have 3 variables. We have the y variable, the x variable, and the t. It's different from here that we have only 2. I know we have 2 types of variables, which are the dependent and the independent. Dependent in terms of y depends on whatever x is. Y is the dependent variable of x. Yx is the independent variable. But in this case, we have 3 variables, all depending on what? On t. Y depends on t, x depends on t. So these 2 here are the dependent variable, y only t is the independent variable for parametrics. And so when we have parametrics equation like this, our derivative will be the y, the t. Find the derivative of this, then divide it by the x, the t. So this for parametrics. Then we have the implicit derivative. Implicit. When you have something like xy equals to a. You know, a there is a constant, can be any number. So it means you are going to find the derivative with respect to x and with respect to y. Then we solve. All this is what we have done last class. But as we go into the application, we'll try as much as possible to explain. As I've said, we don't have much time. Now we're supposed to be in integration. But let's see what we can do today. Alright. Okay. First question. Differential can be applied in different things, in different aspects. We can use it to find velocity and acceleration. That is Remember last semester, for those that did MTH 103, that you are given the S to be something in respect to T. You find the S to T to get your velocity. The second derivative to get your acceleration. So that's one of the applications of differentiation. Another one is applied in tangent and normal to a curve. Another one is application in minima and maximum. So these are some of the applications. Although it's more than this thing, but for now, these are the three that we are looking towards. So firstly, let's start with its application in velocity and acceleration. Not much, we'll just do some little revision of that. Okay. Now this guy says the distance in meters moved by a car in 3 seconds is, let me use a different stuff. Okay. X equals to, let's say, 4 2 raised by 3 minus 3 squared plus 2t minus 5. So if that is the distance moved in meters, we have to determine the velocity and acceleration. At the velocity and acceleration when t equals to 1 second and t equals to 2 seconds. So let's use that. Then. Now, mostly in velocity and in velocity and acceleration, don't mind me, it's as if I'm still sleeping. In velocity and acceleration, so if the distance in meters moved by a car in time t seconds is given as this, so we are given x equals to 4t cubed minus 3t squared plus 2t minus 5. We have to find the velocity, find the acceleration at time 1 second and 2 seconds. So what we have to do is this. Now, if the distance is given in this form, the distance is given as a function. The velocity is the derivative of the distance with respect to t. Now, the derivative of, now, our distance here is x, not s. In some cases, they can give us s equals to, but you go with what you are given. So the derivative of x with respect to t, that's our velocity. For acceleration is the derivative of velocity with respect to t. And what does this mean? It means it's the second derivative of x with respect to t. That's for acceleration. Velocity is the first derivative, while acceleration is the second derivative of it, which means acceleration is the derivative of this velocity. So that's just what we use to get our answers to this. Now, for the first one, to get the velocity now, in terms of t, that's the x dt. Derivative of this will give us 4 times 3, that's 12. Then take a 1 from the power, that's square, 12t squared, minus 3 times 3, that's 6. Take a 1 from the power, that's t, plus, when you have 2t, t means you have t raised to power 1, right? 1 minus 1 is 0. 3 raised to power 0 is what? 1. N raised to power 0 is 1. So that means you have 2 plus 2. Derivative of the constant is what? 0. Constant means the one that doesn't have the t. That's 0. So this is for velocity. So this is the derivative of the distance with respect to t. That's velocity. But now we must put, so now check, when time is 1 and time is 2 seconds, what will be the velocity? So you now say v subscript 1. That means at 1 now. Will be equal to, if you put 1 here, that's 12 minus 6 plus 2. And that gives us what? 8, right? What's our unit for velocity? 8 meter per second. This one also, we can put our meter per second. So that's when velocity, when time is 1, we put 1 in respect to t. Because 1 square here is 1. 1 times 12, 12. 6 times 1, 6. So minus 6 plus 2. But now when time is 2 seconds, so at time 2 seconds, v subscript 2 will be 12 into 2 raised to power 2 minus 6 into 2 plus 2. And that gives us 2 times 2, 4. 4 times 12, 48 minus 12 plus 2. Minus 12 plus 2 is minus 10. 48 minus 10, that's 38 meter per second. So that's the velocity. This is one of the applications of differentiation in velocity and acceleration. Now we've done for velocity. We've gotten the 2 velocities at 2 different times. Now what will be the acceleration? Acceleration with respect to t will be second derivative, or let's say the derivative from here. So derivative of v with respect to t. So the first derivative gives us this. Second derivative means find the derivative of this one again. So that will be 12 times 2, 24. Take a 1 from the power, that's t. Minus, you have 60. That derivative of this will become 1 rather. 6 times 1, that's 6. Minus 6. But what will be the unit for acceleration? Meter per second squared. That's acceleration with respect to t. Now, the acceleration at 1 second and at 2 seconds. So that would be a substitute 1. So putting 1 into this, that's 24 minus 6. That gives us 18 meter per second squared. Then at time 2, that means 2 into this also. That would be 24 into 2 minus 6. 24 times 2, that's 48 minus 6, that's 42 meter per second squared. So this is the answer to this question. So that's one of the applications of differentiation in velocity and at the same time in acceleration. So velocity means you find the first derivative, then put your time. While acceleration means the second derivative, then you also put your time. So that's all. That's for that one. Okay. So the velocity and acceleration aspect is what we have done last semester, but I'm sure that is explanatory enough. The second one is the tangents and the normal to a curve. tangent and normal to a curve. So we can also apply differentiation into tangent and normal to a curve. Now let's see what we can. Okay. Let's say we have a question. Now to determine the equation of tangents and normal, equation of tangent and normal to a given curve, tangent and normal to a given curve y equals to, let me use y equals to x raised to the power of 3 minus 3x squared plus 5x minus 1. Okay. So we have this at point x equals to let me say x equals to 2. Now this question says, now for tangent and normal, I'm going to use when we have an explicit in terms of y equals to the function. Then when we have an implicit, when you have both x and y in the function. And when you have a parametric also. Then also when you have trigonometry. So these 4 things, we are going to talk about them under this tangent and normal to a curve. Implicit, explicit, parametric, and trigonometric derivative. So we talk about the 4 of them. We take example for each of them, then we solve it to get the equation of tangents and normal. Now we know that our equals to n into x minus x1. That gives us our equation of tangents. So we are going to apply this and see how we can relate with this question. So, equation of tangent is this. But now, this is what I normally use for my own workings. First of all, you have to get this is the gradient. The gradient of tangent, that's MT. It is to get the y dx. That's the derivative of this one. But to get the gradient of normal, I call it m subscript n. That will be 1 over minus. So first of all, it's an inverse of mt, but also with minus. The gradient of tangent means the derivative of this one. But the gradient of normal means inverse of it, inverse of the one for tangent is what? Negativity. So first of all, 1 over mt, then I introduce minus. So which means my two equations which I normally use is y minus y1 equals to mt into x minus x1. This one is for tangent. Then y minus y1 equals to nn into x minus x1. This one is for normal. So once you've gotten the first one for the gradient, for the tangent, look for what? The normal, then solve for your what? For your equation. Now, this is the equation. Y equals to x cubed minus 3x squared plus 5x minus 1. So firstly, the derivative. Now, that means divide the x. So to get mt now, gradient, so which is divide the x, will be equals to the derivative of x cubed is 3x squared. 3 multiply 1, take away 1 from the power, from the general line, minus 3 multiplies 2, that's 6. Take away 1 from the power, that's 1. So x is power 1 is something as x. That's 6 minus 6x. Then you have 5x. X then means raised power 1. 1 minus 1 is 0. X raised power 0 is what? 1. So when you have 5x, the derivative is what? 5. And when you have a constant, it's what? 0. Nothing. So this is for the gradient of this. But now, we need to put our value for x into this expression. Now to put our value for x, because in this question, although I come up with the question, it's different from the one that you are given x and y. You're supposed to have 2 points when x is maybe 1 and y is 2. But now I only give us x. Why? Because I know it's a what? It's an implicit, explicit rather. It's an explicit function. We are doing it with explicit derivative, which means it's in terms of x only. There is no x and y in the function. Y is already being made the subject, so it's in terms of x. You don't need the y to solve this one. So it's just x, because what we have here, only x. So that means if we put our value for x, when x equals to 2, but we still use y actually, we still solve y. Okay, when x equals to 2, that means we have 3 into 2 squared minus 6 into 2 plus 5. 2 times 2, 4, 4 times 3, that's 2 raised by 2 is 4. Then 4 times 3, that's 12. Minus 12 plus 5. This cancels this, so that's what? So our mt is 5. Now let's get our mn. So get everything that you need before you now write your equation. Now our mn will be minus 1 over what? Mt. M subscript t. And that gives us minus 1 over what? 5. Now, if you want to continue with this work now to get our equation for tangent and normal, we have x1, which is this one. But we don't have y1, which we are not given. Now, what I will have from the function. So I have to calculate y first before we now make use of it in this equation. Now, how do we get y? So we are going to put x equals to 2 into the equation of the curve. So I'm going to put x equals to 2 into this place. We get our y. Then after that, we get the equation of the tangent and that of the normal. So now for the equation of the curve, we are given from the question that we have y equals to x cubed minus 3x squared plus 5x minus 1. Now, when x is 2 here, That means we are going to have 2 raised to power 3 minus 3 into 2 squared plus 5 into 2 minus 1. 2 raised to power 3 gives us 8. 2 times 2 times 2, not 2 times 3, but 2 times 2 times 2. That's 8 minus 2 raised to power 2 gives us 4. 4 times 3, that's 12, plus 5 times 2, that's 10, minus 1. What's the answer to this? 8 minus 10 minus 12 plus 10 minus 1 is what? Huh? 5. 8 minus 12, that gives us minus 4. Minus 4 plus 10. Okay, minus 4 and minus 1, that's minus 5. So 10 minus 5, that's also 5. So our y is also 5. So we continue from there. So our y is also 5. So y is 5. So x is 2 and y is 5. So our equation now. So equation of tangent. So y minus y1, that's y minus y1 is this 5, equals to our mt is 5. These are mt here. Our mt is 5. That's 5 into x minus our x1 is 2. If we solve for that, we are going to have y equals to, let this minus 5. So the other side becomes what? Plus positive 5. That's 5 plus. Now 5 times x, that's 5x. 5 times minus 2, that's minus 10. I hope you get what I did there. I expand this bracket to get this one. Then I bring this minus 5 to come in. Now you have 5 minus 10 gives us what? Minus 5. So that means y equals to 5x minus 5. That's your equation for the tangent. Now for the equation of normal. For the equation of normal, using the second one now. So y minus y1 is still 5 equals to, now that's minus the inverse of this, which you have gotten to be what? Minus 1 over 5 to be our gradient of the normal. That's minus 1 over 5 into x minus 2. If you solve for that, 5 goes to the other side the same way. That's y equals to 5 minus. This one will become, now you have minus 1 here. Minus 1 times x, or let's say, let the minus stay as it is. We have minus, then we have x minus 2 over 5. What did I do here? Only 1 to multiply this. The minus is still as it is. Only 1 to multiply, the minus is still as it is. Now, we find the LCM between the two. Y equals to 5. 5 times 5, that's 25. Now, this minus will not affect the two of them. So, minus times x, that's minus x. Minus times minus, that's plus 2. 25 plus 2, that's 27. Y equals to 27 minus x over 5. This is the equation for the normal. So when you are given an explicit in that form, so you get your x and your y. If you are not given y, you look for your y. Then get your gradients. Gradient means derivative of the curve itself. So after getting the gradients, then get your, that's your gradient of the tangents. Now get your gradient for the normal. Your gradient for the normal is minus 1 over gradient of tangents. Then after that, use your equation for tangents and normal. Then you have your answers. That's for explicit. That's for explicit. Then we can also have implicit too. Let me see the question. What are the, you are the introduction, or which part is going to be? You don't understand. that's for implicit. This for explicit. X, like it's outside. In is inside. So explicit means the y is already outside. Then the implicit means the y will be inside the function. So let's check the question. Okay. So we have to find the tangent and normal of the curve x squared plus y squared minus 2x minus 6y plus 5 equals to 0 at x equals to 3. At x equals to 3, y equals to 2. So we have to get the tangent and normal of this at x equals to 3 and y equals to 2. Now this is an implicit function. Implicit function. So which means we are going to find its derivative, then after that, which will give us our gradient. Then we find the gradient of the normal, the equation of tangent and normal. So this is the points where we need with later. Now we have x squared plus y squared minus 2x minus 6y plus 5 equals to 0. Now what's the derivative of this? That means our gradient m of t now. That's what we want to find. We want to find the gradient. Now this one is not just divide the x equals to, no. It means we are going to find the derivative of each of them based on their position. Now we have x squared. When you find the derivative of x, we are going to have that. But when you find the derivative of y, we will include what? Divide dx. Now let's see. This one we have 2x plus derivative of y squared is what? 2y. But when you find the derivative with respect to y, so that means we are going to add y dx to this one. Then minus derivative of 2x is 2. Minus 2 minus derivative of 6, that's minus 6 dy dx when it's respect to y. Then constant is 0. So equals to what? 0. 5 there is a constant. Derivative of the constant is 0. So that's plus 0 equals to 0. That's what we have there. Now this one is quite simple because in some case you might have, let me show you this one. You might have 2x squared y cubed. 2x squared y cubed, maybe plus 5 equals to 0. Let me just divert it to explain this. Now, if this is an implicit function and you have to find its derivative, it means first of all, you find the derivative with respect to x. Now, this one first. Meaning that all of that things will be coefficients. 2y cubed will be the coefficients. Now, x squared, that means 2 will multiply this one, right? So it becomes, that's times 2. Then x, take a 1 from me, that's times 2x. Right? So first of all, you find the derivative with respect to x. That means all of that things will be the what? Will be the coefficient, which is a. That's 2y cubed. Then the derivative of x squared alone is 2x. So when you multiply these two, you have 4xy cubed, alphabetical order, x before y. But we must still find derivative of this one again, because you have both x and y. So when it's only x, you firstly find for the x. Now, the same thing you also do for y. Now, instead of with respect to x now, with respect to y. Now that means 2x squared becomes the coefficient now. That's plus 2x squared. 2x squared becomes the coefficient. Now, derivative of y cubed is times 3y squared. Then you now have what? The y dx. So this second one we have the y dx. So that's 4xy cubed plus 2 times 3, that's 6 plus 6x squared, y squared, dy dx. This is a constant, that's 0, so equals to 0. So that's what you do. When you have two things, like for example, this place alone can be like this. So this one alone will give you two things. The first one with respect to x, the second one with respect to y with what? Dy dx. Then you make your dy dx the subjects. So that's what we are going to do. So that's what we do in implicit. Can I rub this one? It's not part of the workings, but I'm just showing what you do when you have situations like that. Okay. So this is not part of the working, so just to show when you have that type of equation. Now, we continue from here. Now we have 2x plus, so we find the derivative of this, we have 2x. This gives us 2y divided dx. This gives us minus 2, minus 6 divided dx, constant, equal to 0. Now what next? We take the divided dx together, and the other one together. So that means we have 2y divided dx minus 6 divided dx plus 2x minus 2 equals to 0. The one that is having divided dx together, the one without divided dx together. Now, the ones without divided dx, these two now, we go to this side. So that we'll be left with this one here. So that means we have 2y. Okay, let me take it step by step. Divide dx minus 6 divide dx equal to. Now, minus 2 will come to that side, become positive 2. Then plus 2x will become minus 2x. That's what we are going to have when you collect the like terms. Then divide dx is common between these two. So that means you have 2y minus 6 into the bracket of what? The y dx. To be equals to 2 minus 2x. Then what's our divide dx? So divide dx. So you divide both sides by the what? By the brackets. So divide dx equals to 2 minus 2x all over 2y minus 6. So if you are just asked, maybe just for a normal question, find the derivative of this implicit function. This is just what you do. But now we are applying it in the tangents and normal. So this is the first step. Find the derivative. So that means our MT. Now we are going to put our points to now get it in the simplest form. Any question on this step? Okay. So next, our x is 3, while our y is 2. So when you put it here, we are going to have this minus here, this minus. So when you put it here, we are going to have 2 minus X is 3. 3 times 2, that's 6. All over. Y is 2. 2 times 2, that's what? 4. That's 4 minus 6. 2 minus 6, that's minus 4. 4 minus 6, minus 2. 2 divided by minus divided by minus is what? Plus. It's empty as minus times minus, plus. Then 4 divided by 2 is what? 2. That means our empty is what? 2. Now if our empty is 2, what's our MN? Minus what? Minus 1 over 2. So this is the gradient of the tangents, and this is the gradient of the what? Of the normal. Then we are going to take our equation of tangent and normal, then get our equation to that. Now equation of tangents. That's y minus y1 equals to nt into x minus x1. Now we have y minus, y1 is given from the equation which is 2. Y minus 2 equals to, our nt is 2. 2 into x minus x1 is 3. If you solve for that, y equals to 2. Positive minus 2 becomes positive 2. Then expand this one. That's plus 2 times x, that's 2x. 2 times 3, that's 6. 2 minus 6, that's minus 4. So y equals to 2x minus 4. That's the equation of the tangents. Then we have the equation of the normal. That's the same, this, but y minus y1 equals